Hi guys, this is Ms. Prasad here. Now, if you're planning to excel at the CSEC level, you are definitely at the right place. So in these videos and upcoming videos, you will be learning about everything you know for CXC and beyond. But I have a condition. For us to begin today's video, you are required to get a notebook, pencil, pen, ruler, and eraser. In this video, we'll be focusing on section A of the syllabus, which is the organism and its environment. More details, we're going to look at matter. Now, the upcoming videos will be focusing on cell, diffusion and osmosis, and microbes. But for this video, we are focusing on matter. Now heading into our video. What is matter? I'm sure you heard of the word before. What is matter? Matter is anything that has mass and occupies space. That's a very, very simple definition for matter. Matter is anything that has mass and occupy space. Now, going into the bigger question. Matter is anything that has mass. But what is mass? Now, many people say mass and weight is the same thing. However, that's a totally wrong concept. Mass and weight is not the same thing. Now, mass is the amount of particle an object is made up of, or an amount of molecules an object is made up of. Whereas a weight is a force that is caused by gravity, and it acts upon mass. So let me give you a little scenario to make it more clear. Let's say we have a bag of potato. Maybe 10-pound potato. We weigh it on earth, it's 10 pounds. And you know the potato have the same molecules and so on. Right? So we weigh it on earth, it's 10 pounds. Now if we carry it in space, do you think it will weigh the same 10 pounds? Do you? No, it's not. It's not going to weigh the same 10 pounds. Reason why? Now there is more gravity on Earth than up in space. Hence, and we say weight is the gravity exerting on an object. It's caused by gravity, basically. So the weight will change. However, the molecules that make up the potatoes, that's a mass. Remember, we say the mass is the molecules, right? So the molecules that make up the potato will not change. We have the same potato on Earth. It's the same potato we carry in the space. So the mass, the particles that make up the potato will not change. However, the weight do change because of the gravity. So that's the difference between mass and weight. And then we go further, we say takes up space. So when we're talking about taking up space, we're talking about volume. So anything that take up space is we're talking about the volume. So matter is anything that has mass and takes up space, or you can say it has a volume. Okay? We have 4 states of matter. Can you name them for me? You might be familiar with 3. We have solid, liquid, gas, and plasma. So there is 4 states of matter: solid, liquid, gas, and plasma. So I'm sure you know examples of solid, liquid, and gas. But I'm not sure if you know example of plasma. Now, plasma, two example of plasma, it's lightning and northern light. So that's two example of plasma. Now, why is plasma different from the other states of matter? Now, plasma is different because it have ionized gas. So plasma is not a normal gas. It deals with ionized gas. So we have solid, liquid, gas, and we have plasma. And two examples of plasma, we have northern lights and lightning. Okay? Now we're going to focus on the properties of matter. We have five properties here. Saw them? We have arrangement of particles, shape, volume. We have particle force, and then we have movement of particles. So we are not going to focus on plasma, but you just need to know what is plasma, an example of plasma. So we are not going to focus on plasma. We're going to focus on solid, liquid, and gas. So the arrangement of particles. Now, in a solid particle, solid particles are closely packed, right? And they are arranged in a regular way. So in a solid, the particles are closely packed. Whereas in a liquid, the particles are randomly arranged. Hence, they are in clusters. Hence, they are slightly closely packed. It's not that compressed as a solid, but particles are free to move in a liquid. They are close, but they are free to move. They are not that close again. So the solid are more close than liquid particles. So liquid particles are in clusters, and they are allowed to glide over each other and move around a bit. Whereas in gas, particles are further apart and they are randomly distributed. I mean, they can bounce. They're allowed to bounce all over the place. Right? So in a solid, they are closely packed. In a liquid, they are in cluster. They are allowed to move. And in a gas, they are further apart. We're going down to the shape. Now, when we're talking about the shape of a solid, now the shape of a solid is a fixed shape, right? Solid keeps its own shape. It's a fixed shape. Whereas in liquid, the liquid takes the shape of the container. So liquids can pour, right? So whatever containers you put them in, they will take the shape of that container. However, a solid will keep its shape. As we say, it's fixed. A liquid shape is not fixed. It will keep the shape of its container. And in gas will take the shape of the container. The entire container gas will take the shape of. When we're looking at the volume, in solid keeps its volume. You have a fixed volume. Okay? And the liquid also keeps its volume. So hence, A more better example, if you are pouring 1 pint of liquid from a cup into a bottle, it would not change. The volume will not change. It would be the same amount of liquid. Isn't that so? Good. So a liquid takes the shape of a container, but it keeps its volume. A solid also keeps its volume. Whereas in gas will take the volume of its container. So how big the container is, the gas will take the volume of the entire container. Now we're going to look at interparticle force. Interparticle force. In a solid, the force is very strong. Now, for molecules to keep together, there are forces in between, right? Nothing can stay together if there are nothing holding them together. So there are forces. So in solid, because they're closely packed, they are strong forces. There's a strong force there. The force there is stronger, hence it's closely packed and it's not allowed to move. Whereas in a liquid, it's moderate. It's in between. It's not that strong, but then again, it's not freely to jump about or to move. It's still intact a bit, but it's not that strong as a solid. Whereas in a gas, it's very, very weak because particles are free to move wherever they want to. Once they can move, they will move. So they are not much force. They are force, but they are big or little force in gas. We have movement of particles. So in a solid, the particles would vibrate. That's how the particle would move. It would vibrate in a fixed position. In a liquid, particles can flow past each other. They can flow, overflow, pass, whatever you may say. And in a gas, individual particles move quickly and randomly. So the movement of particles in a solid, they're fixed. They just vibrate. That's all they can do, vibrate. In a liquid, they can flow past each other. And in a gas, they can move very quickly. Okay? So that's a property of the 3 states of matter. So when we are talking about the properties, we can use the arrangement of particles to describe it. We can use the shape. We can also use the volume. We can talk about the force. We can talk about the movement of particles. So all of those are properties. Now we are looking at changing of states. Now changing of states, as we learned, there are 4 states, right? So now we're moving from one state to another. That's what they meant by changing of state. So it's summed up in this diagram here. So the diagram, we have the solid, liquid, and gas, as we talked about before. Now, we do know we have some substance. They're in solid one period of time, and they can change to a liquid. For example, ice. As you know, ice is solid water, right? So a solid ice can turn into liquid. So that's moving from one state to another. So that's what we meant by changing of states, is moving from one state to another. So for a solid to move to a liquid or to get to a liquid state, we need to apply heat. Now you may say you're not applying heat to ice, but ice do melt, isn't that so? Now the environment, even if you are not applying heat to the ice, the environment is applying heat to the ice. There is a warm environment. Hence, for anything to change from solid to liquid, that process is called melting. We need to apply heat, right? So heat is applied to change something from solid to liquid, and that process is called melting. Okay, let's say we have the liquid. Now, and we want to change the liquid to gas. So what do? We apply heat energy to the liquid, and then the liquid would change to gas. And that process is called evaporation. The process where liquid is changed to turned to gas, that process is called evaporation. Now, the opposite can occur. See, we have another arrow going back. The opposite can occur. We can change a gas or condense a gas to a liquid. Right? We can turn a gas into a liquid by removing the heat energy. Remember, we were applying heat energy from liquid to gas to turn gas. Now, if we want the reverse to occur, we need to remove the energy now, the heat energy. So once you remove the heat energy, that substance can turn to a liquid back, and that process is called condensation. So the process where gas turns into a liquid, the process is called condensation. So now if we want to change a liquid to a solid, that process is called freezing. So again, to change a liquid to a solid, we need to remove the heat energy. So when you remove the heat energy, that process is called freezing. The process moving from liquid to solid is called freezing. So to moving backwards, we need to remove heat. And to move forward, we need to apply heat or supply heat. Now, there's also a state where solid can change directly to a gas without turning a liquid. A solid can change directly to a gas, and that process is called sublimation. And you apply the same heat, apply heat to solid, and the solid would turn into a gas. That process is called sublimation. Now, if you want to turn gas straight back to a solid, that process is called, what is that word? Deposition. So that process is called deposition. So changing from gas to solid, that process is called deposition. And we're removing energy. As I said, if we're moving backwards, we're removing energy. So here we have notes. They're defining what is melting, evaporation. We have sublimation here. And one iodine. Iodine and dry ice does sublime. So that's an example. Alright. So iodine and dry ice does sublime. So they go through the process of sublimation. Okay. So there we have it. Everything on matter. Now what you're going to do for me in your notebook now, you're going to open your notebook for me, and without looking back at this video, try to define the term matter. So you're going to define the term matter. Just write a simple definition of what is matter. Then you're going to, next subheading, you're going to head up states of matter. Then you're going to list the 4 states of matter for me. which is solid, liquid, gas, and plasma. You're going to list it for me. Then you're going to give me examples of the 4 states of matter. Example of solid, example of liquid, example of gas, example of plasma. You're going to give me that. And then you're going to construct a table with 4 columns, but 6 rows. 4 columns, 4 long way, and 6 rows. Okay? Now, in the first column, you're going to head up the same way here, properties, solid, liquid, and gas. You're going to head up the same way. Then you're going to write, in the first part, you're going to write arrangement of particles. Then you're going to draw a line, write shape for me. Then draw a line across. Then you're going to write volume. When you finish writing volume, draw a line straight across. Then you're going to write interparticular force. Then you're going to draw a line straight across and then write movement of particles. Now for the main part, you are going to fill up these spaces, the column, without looking at the video back. So when you see arrangement of particles, you're going to tell me, you don't have to remember everything. You're going to think, how is the solid particle arranged? They are closely packed. That's correct. They are closely packed. Now, in a liquid, they are in clustered, or they're not that closely packed as a solid. That's correct. In a gas, you can say they're further apart. That's correct. So you're not remembering everything, but I want you to complete this table without looking back at this video. The same thing goes to shape. You're going to think about how does the shape, is the shape definite? It is fixed, or does the shape change? So you can say the solid keeps its shape. That's correct. And then you can say the liquid takes the shape of the container, and then the gas also takes the shape of its container, the volume of its container. Yep. And the same thing you're going to do for force and movement of particles. So you're going to fill up this table without looking back at the video. Okay? And then we're going to do, you're going to head up changing of states for me. When you head up changing of states, you are going to write solid, just like how they have it here. Solid, liquid, and a gas for me. Then you are going to put in the arrows without looking at the video. Put in the arrows and then name the processes for me. Name the processes. So to move from solid to liquid, you're going to say that process is called melting. So you're going to put melting to the arrow, then you're going to put freezing and so on. So you got to remember the names. You got to know to spell them also. Don't forget you have to put in heat energy at the top and applying heat energy, and then you can put removing heat energy at the bottom. So without looking at the video, you are going to put in this labeling for me. Okay? Then after putting in the label, you are going to define each one of these terms to me. You're going to define melting. For example, I'm going to define melting for you. So when you finish writing this, you can put melting is the process whereby solid changes to a liquid by applying heat energy. Think you understand it? So we can say melting is a process whereby solid changes to a liquid by applying heat energy. You can say for evaporation, evaporation is a process whereby liquid turns to a gas by applying heat energy. So that's basically, you can even look at the diagram and make up your definition. Okay, so you're going to do that for me. Once you can do those things without looking back at this video, means that you have grasped all the concept. You have grasped everything that you need to know about matter. Okay, so you can go ahead and do your work. See you in the next video.